Yeah, so even though AI has come a long way in the last few years, there are some bottlenecks that are emerging. One of them is Moore's law itself, actually. So while we have been able to continuously increase the number of transistors per surface area, we have gotten to a point where power is not decreasing as fast as before. So the frequency of these transistors is tapering out. And so we're hitting a limit here where the number of parameters is actually growing much faster than the number of transistors or the computational capability. And as that has progressed and continues to progress, the outcome is that the subsequent generation of models becomes progressively more expensive to train. In addition to hardware performance, another limiting factor is the amount of data. As these models get larger, we need more and more data to fully train them. When we look at large language models today, they have already been trained in the entirety of the internet. Presumably, they have also used all the digitized books and textbooks, and so there isn't much more data to use. We do have perhaps chat data or email data, but a lot of experts think that there is too much redundancy and that the quality of that data is not very good, and so models won't get that much better by utilizing that. We're still in the early innings of AI, so these problems are not unsurmountable. So there is a lot of things that people are doing to overcome them. On the hardware side, there is very smart people building custom chips whose only purpose is to operate a single type of model. So we can squeeze a lot more power out of the same number of transistors. On the algorithm side, we've had the same kind of ideas for the most part that we had several decades ago. So we're a few new ideas away from being able to also get more performance from the same hardware. In terms of the data limitations, it seems that when it comes to text, we have reached an asymptote in how much value we can get, but there is other types of information that we can use. For example, we have a lot of video out there, and while a lot of machine learning models have been processing videos, for example, recently we saw the model called Sora by OpenAI that is doing generative work with videos. We're not using videos to their full capacity. Videos actually could help us develop a world model. So by looking at enough videos of nature, for example, a model will be able to learn about the laws of gravity. And so if we can make some advances to be able to extrapolate this kind of information, we could actually advance a lot in our learning. Then there is this whole idea of reinforcement learning. This is when machine learning models can learn from interacting with the environment on their own. You may have heard of this when talking about machine learning models that learn how to play video games by interacting with the game directly. The same can be done for other things like large language models. We could make them, for example, talk to each other, similar to what we saw in Westworld, where robots continue to talk to each other even when humans weren't around.